could you ever forget that?
All right, so quadratic functions. In Chapter 8, Section 3, we're going to be looking at the quadratic functions. And you need to know some terminology. The quadratic functions have 3 different forms. One form is when you have the a x minus h quantity squared plus k. That is a technique that's going to be completing the square. This is called vertex form. You need to write that down because when you have it in vertex form, the h and the k, it's your vertex. That's your maximum or your minimum value. If you have it to where it's ax squared plus bx plus c, that's standard form. And in standard form, if you were trying to find the x-intercepts, that's when you would use like your quadratic formula, okay? You can't use the quadratic formula if it is in vertex form. Now, there is something that both of these have in common. These a values are going to be the same. If that a value is positive, your parabola, which is the name of the graph of a quadratic function, points up. If that value is negative, it's going to be turned upside down. When you graph these for me, you're going to have to show me this dotted line that is the axis of symmetry. The axis of symmetry goes through the vertex. If it's in the HK form, that vertex form, the H value, the opposite of that sign, is going to be the X equal to for this axis of symmetry. Are you okay with that? Does that kind of make sense? Okay, so we're going to graph x squared minus 2. When we're graphing x squared minus 2, there's some things that you need to keep in mind. It's an x squared. It's a quadratic equation. I know that I have a positive a value, so I know that this parabola is going to point up. What do you think this minus 2 does to the parent function? Transformations from geometry. What does the negative 2 do to anything? It makes it lower by 2. So instead of starting at 0, 0, if I substitute a 0 in for the x squared, I'm going to start at 0, negative 2. If I put a 1 in for my x, what's 1 squared? Minus 2. If I put a negative 1 in, what's negative 1 squared? Minus 2. So I know how wide my parabola is going to be. Okay? So far, so good? We're really going to be looking at transformations of graphs. If I put a 2 in front of the x squared, what do you think the 2 does to my parent function, the x squared? What does the 2 in front of any function do? What does a 2 in front of a y equals mx plus b? What does it do? If you have 2x, what does it do to your line? It makes the slope steeper, right? So if I type into my calculator the 2x squared and the x squared, the first one that graphs is going to be the stretched version of the parent function. We say that is a vertical stretch. If you have a number that's in front of the x squared greater than 1, it's a vertical stretch. What happens if that number is between 0 and 1? What do you think it's going to do? Everybody's afraid to talk. It actually is a vertical shrink or compression. The original graph is the one on the inside. The y values are getting smaller, so the graph appears to be getting wider. That's called a vertical stretch. You have to use that terminology. Okay? If you have a negative, what did we say the negative would do? What is this called? If it was pointed up and then it's pointed down, what is the terminology for that? From geometry, what has it done? Flipped is not the geometric term, but that's the one that most students use. It's a reflection about the x-axis. So I need you to use the word reflection, okay? All right, so let me get rid of this one. And, whoops. If I'm going to add x minus 3 inside of the parentheses, who can remember what this inside the function, how does that affect the parent parabola? It makes it go right or left. Does minus 3 make it go right or left? Here's the parent function. It's going right. The reason why is because your zero value inside the function, you have to add or subtract the opposite of what's already there. So if you have x minus 3, then the 3 minus the 3 gives you a 0. Inside the function is always opposite of your sign. If I have x plus 3, then this one is going to go left 3 units. So my vertex is negative 3, 0. You okay with that? I will expect you to be able to do this graphing without a calculator, looking at transformations only. Okay? Let's see if we can put it all together then. If I have a 3 in front of parentheses, what does the 3 do to my graph? What did the 2 do to the parabola? If it was just 2x squared, what did that one do? What is that called? It's either a shrink or a stretch, right? So does the 3 vertically stretch it or shrink it? Did it go narrower or wider? It went narrower. Think of a little kid or you stretching. If it's greater than 1, it's stretching up, right? Up is vertical. So it's a vertical stretch by a factor of 3. If I have an x minus 2, what does the negative 2 do to my parabola? It moved it to the right 2 units. And then if I stick a plus 1 out here, what does that plus 1 do? That's the one that moves it up 1. Now, the 2 affects the x values. The 1 and the 3 affects the y values. So looking at this graph, a parabola normally starts at 0, 0. And it has moved right 2, up 1. That's your vertex that you're going to start graphing. Parent function moved right 2, up 1, and stretched by a factor of 3. Is that kind of starting to make sense? And I do expect you to use some of that terminology, okay? So if you're going to graph y equals a negative 1/2 x plus 1 squared minus 3, then you would typically just type that in the calculator, right? If I ask you to describe the transformations, what does the negative do? Reflection about the x-axis. What does the half do? So it is a vertical shrink or compression. What does the plus 1 do?
We go left.
It would go left by 1, and the plus 3 or minus 3, and that moves it down. So where is my vertex? Where's my starting point? Where's the vertex?
It would go to 1.
-1, -3. Now, I mentioned the axis of symmetry. The axis of symmetry goes through the vertex. When I go to -1, -3, I'm going to put a dotted line. X equals -1. This dotted line is the axis of symmetry. And if you have a sibling right now in Algebra 1, they're learning the exact same stuff. Not as detailed and not as much stuff, but they are starting with the vertex and the axis of symmetry in the 3 forms that you can have it in.
What did you still not graph? That's just something.
First off, you're going to graph the vertex, -1, -3. From the -1, -3, we're going to put your axis of symmetry at x equals -1. Okay? The next thing that we're going to do is we're going to reflect it because it was a negative, and we're going to make it wider. If I put a 0 in for my x, what is 0 plus 1? What's 1 squared? What's half of 1? So it's a half. Are you with me? What's a half minus 3? 3.5. 1, 2, 3.5. So when we substitute the 2 in, we get a -3.5. If I mirror this over to the other side, because it's the axis of symmetry, I know how wide to make my graph. Kind of making sense?
Is that a 7/2?
Yes.
Okay.
3.5 is 7/2.
How does it matter if it's really close enough to a graph? Wait, what did you lay graph?
Yes.
What did you just say 0.5 minus 3 was?
It's -1/2 minus 3.
Oh,
This is a negative.
that's why you got me confused.
Oh, yeah, no. Yeah, it's 2.5 if you've done 1/2 minus 3. Okay, so that's how I'm going to kind of expect